Today we're going to take a look at how to solve trig equations by factoring. So we're really combining two concepts we've already seen, so hopefully today's lesson is fairly straightforward. So our first equation is cosine squared minus 1. So hopefully you recognize that as a difference of squares. So we're going to factor that into conjugates, cosine x plus 1 and cosine x minus 1 equals 0. We've got our unit circle here to remind us of where our answers are going to be coming from once we set up our equations. So next we're going to set each binomial equal to 0. Remember, this is zero product property. So we've got cosine x plus 1 equals 0 and cosine x minus 1 equals 0. So solving those equations, we're going to be looking for where the cosine equals negative 1 and where cosine equals positive 1. So to do that, we're going to remember that cosine is our x value. So our x value is positive 1 over at 0 degrees and negative 1 over at 180 degrees. So here x equals 0 degrees at the positive 1 and x equals 180 degrees at the negative 1. Our next equation, we want to set it equal to 0 before we solve. And with my unit circle here, I'm probably going to run out of room, so I'm going to do this below my unit circle. So I'm going to subtract the 3 sine squared x, and I'm going to write this in standard form. Hopefully this is semi-legible for you. Next, I notice that all 3 terms have sine x. So I'm going to factor out the GCF, and then what's left, I've got 2 sine squared x minus 3 sine x plus 1. So after factoring out the sine x, we're left with an AC method. So when we set up our t-chart, we're really looking at what multiplies to 2. That comes from this 2 being multiplied by this 1. And we are going to be adding to negative 3. So negative 2 times negative 1 and negative 2 plus negative 1 work for that. So remember, when we're doing AC method, we have to rewrite this as grouping. So our GCF we can't lose, and we've got 2 sine squared x. We're going to rewrite that middle term as negative 2 sine x minus sine x plus 1 equals 0. Now we're going to factor by grouping. So we're going to pull out the GCF from our first 2 terms, and then we'll find the GCF from our second 2 terms. Again, keeping our original GCF of sine x, and then the GCF for our first 2 terms is 2 sine x, leaving us with sine x minus 1. And the GCF for our second 2 terms is negative 1, or just a negative sign, leaving us with sine x minus 1 equals 0. Make sure if what you've factored out, what's left isn't the same, to go back. It's probably a sign that you lost somewhere. All right, so keeping again that original sine x for GCF, and now we're going to factor the grouping. They both have that sine x minus 1 in common, and what's left is the 2 sine x minus 1. So this one, we have 3 sets of terms equal to 0, or being multiplied by each other, that we need to set each of them equal to 0. So our first is that original GCF that we factored out, sine x equals 0, or sine x minus 1 equals 0, or 2 sine x minus 1 equals 0. So let's finish solving, and then we'll take a look at where on the unit circle we get each of these answers. So that first one is sort of solved for. We've got our sine x equals 0. The second one, we're looking for where sine of x equals 1. And the last one, when we add that 1 to both sides and divide by 2, we're looking for where sine is equal to 1/2. So on the unit circle in radians, sine is our y-coordinate. So we're looking for where the y-coordinate is 0, so that will be at 0 radians for our first solution. Our second solution, we're looking for where the sine is equal to 1. So when we scroll back up, sine again is that y-coordinate. So sine is 1 at pi over 2. So that's our second solution. And our third solution, we're looking for where sine is equal to 1/2. Now this time we will have two solutions. Sine is our y-coordinate. It's equal to 1/2 in the first quadrant, and our y-coordinate is positive in the second quadrant. So our third solution is really two solutions, pi over 6 and 5 pi over 6. For our third equation, we're going to start this one the same way. We've got to get it set equal to 0. So we have tangent squared minus 2 tangent x minus 3 equals 0. And then this one is a normal t-chart, but multiplies to -3 and adds to -2. So that would be -3 and +1. So we've got tangent minus 3 times tangent plus 1. Using zero product property, setting each term equal to 0, we're looking for where tangent x minus 3 equals 0 and where tangent plus 1 equals 0. So solving each of these, our first equation, we're looking for where the tangent is equal to 3. And our second equation, we're looking for where tangent equals -1. Now, I don't know how many of you have the tangent functions memorized. Again, in the first quadrant, tangent is √3 over 3, 1, and √3. Notice none of those are just plain 3. So to solve our first one, we're going to use our calculator. We were asked for our answer in radians, so make sure you are in radian mode, and you will just get a decimal approximation. So I got x is about 1.249 for our first one. We're going to come back to this because there is a second answer, but it's helpful to see the unit circle first. So let's also solve our tangent x equals -1. So remember, tangent is negative in the second quadrant when the cosine is negative and the sine is positive, and the fourth quadrant when the opposite is true. Tangent is positive in the first and third quadrants when the sine and cosine have the same positive or negative sign on them. So we have 3 pi over 4 and 7 pi over 4 for our answers for the second one. And the way we could get that second answer, knowing just the first one, because that's what we have for the equation we solved over here, we have just one of the answers. Let's again take a look at this unit circle and see how these answers relate to one another. It is halfway around the unit circle, which is pi. So to get our second answer for where the tangent of x equals 3, we will add pi to the answer we already have. So our second answer is about 4.391. Anytime you are not exactly on one of the axes for the unit circle when you're solving a trig equation, you should have two, because all of the functions have the same value in two places on the unit circle. So again, reminding ourselves, cosine is positive in the first and fourth quadrants. So of course then it's negative in the second and third. Sine is positive in the first and second quadrant, and of course is negative in the third and fourth. And we just looked at tangent, which is positive in the first and third quadrants, and then negative in the second and fourth. So keep those in mind. Here is your U-Try question. Good luck, and if it helps you to feel better, we are spending 2 days on solving by factoring.